Okay, so the Bernoulli distribution models a single trial whose outcome can be classified as either a success or a failure. A random variable x is said to follow a Bernoulli distribution with parameter p if, so this is just the notation for x following a Bernoulli distribution with that parameter p, where p is the probability of success. So naturally, if the Bernoulli distribution represents a single trial and its outcome, right, x can take on one of two values. It can take on 1 if the outcome is a success, and it could take on a 0 if the outcome is a failure. Okay, so in order to get this probability of success, right, we construct this probability mass function as follows. So the probability that x is equal to x is equal to p to the x times 1 minus p to the 1 minus x, where x can take on those values 0 and 1. And using this PMF, we can get p is equal to the probability that x is equal to 1, aka p represents the probability of success, and we can get 1 minus p equals the probability that x is equal to 0, aka the probability of failure, right? Okay, so in order to showcase that something is a distribution, we have to show that the sum of all the probabilities is in fact 1. So the first thing I'm going to do is I'm going to show that p is in fact equal to the probability that x is equal to 1 using the PMF. Okay, so the probability that x is equal to 1 is equal to, so using the PMF, that's p to the 1 times 1 minus p to the 1 minus 1. 1 minus 1 is 0. Anything raised to the 0 is 1, so we're just left with p. All right, and the probability that x is equal to 0, this is p to the 0 times 1 minus p to the 1 minus 0, right? 1 minus 0 is 1. 1 minus p to the 1 is 1 minus p. And of course, p to the 0 is 1, right? So that's how we get the probability of success and the probability of failure using our PMF. Okay, so now let's go ahead and verify that this is indeed a PMF, right? Using the fact that all the probabilities need to add up to 1. So that's x from 0 to 1 of the probability that x is equal to x. So the first one is the probability that x is equal to 0, and then the second one is the probability that x is equal to 1. And we've already calculated these. So this is 1 minus p plus p, which is indeed 1. So this is actually a PMF, right? Because the sum of all the possible probabilities in the distribution is 1. Next, we're going to calculate the expectation and the variance and the standard deviation so we can put the whole distribution together. All right, so let's go ahead and move on to expectation. Okay, so the expected value of x, where x follows this Bernoulli distribution, is the sum from x equals 0 to 1 of x times the probability that x is equal to x. Maybe I can do a better job here. Let's see. There we go. There we go. Okay, and this is equal to 0 times the probability that x is equal to 0 plus 1 times the probability that x is equal to 1. And then that's going to be equal to 0 times the probability that x is equal to 0 was 1 minus p plus 1 times p, which is p. So the expectation of a random Bernoulli variable, right, is p. Now let's go ahead and move on to calculating variance. So variance. So remember, with variance, the variance of x can be calculated as the expected value of x squared minus the expected value of x squared, right? Okay, so of course we need to get this expected value of x squared first. So expected value of x squared is equal to the sum from x equals to 0 to 1 x squared times the probability that x is equal to x. And then this is equal to, so it'll be 0 squared times the probability that x is equal to 0 plus 1 squared times the probability that x is equal to 1. That's 0 squared times 1 minus p plus 1 squared times p. And as you can see, it's going to be p, right? Because 0 times anything is 0. 1 squared times p is still p. So now we can calculate variance. That's equal to the expected value of x squared minus the expected value of x squared. And that's going to be, we just calculated this. This is p minus, and this is going to be expected value of x is p, and then we square that. So it is p minus p squared, and we can factor that to get p times 1 minus p. So that is indeed the variance of this Bernoulli distribution. And, you know, of course, variance is also represented as this, right? So the standard deviation of x, where x is a Bernoulli distribution, is equal to p times 1 minus p, which means we can calculate the standard deviation, right? So that means the standard deviation of x, which is also sigma sub x, which is the square root of sigma x squared, which we know is the square root of p times 1 minus p. All right, and now this is pretty much it for the Bernoulli distribution. Okay, we know that it is indeed a distribution because the sum of all the probabilities is 1. We can see the expectation of the distribution is p. The variance of the distribution is p times 1 minus p. And the standard deviation is the square root of p times 1 minus p.